Sorry, I apologize for the for the overflow that kind of cut me off with this last example. So I'm going to do this one more time and then leave you instructions for the classwork for the remainder of the day. So again, here's this last example number 8. And just to clarify, I didn't say this before, but this vertical line here is an asymptote, and also this horizontal line is an asymptote. So let's keep that in mind when we're answering these questions. The first one being find the limit as x approaches 3 from the left. So again, if I take a look at approaching the x value of 3 from the left-hand side, it is getting extremely close to that asymptote. It's going to continue to go up, 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 but it's never going to cross that asymptote. So therefore, the y value is going to continue to increase. So the y value is going to approach positive infinity. As I approach 3 from the right-hand side, as in example B, or question B rather, again, it's going to continue to increase and go up and up and up, never crossing over that asymptote. So therefore, it is going to continue to increase. So the limit is positive infinity. Since both the left-hand and the right-hand side have a limit of positive infinity, then the limit as x approaches 3 in general is going to be positive infinity. Again, remember that f of 3 means what is the value when x is 3, what is the value of the function. And in this particular case, the value of 3 is where our vertical asymptote is. So therefore, the value of 3 doesn't actually exist, but instead of writing does not exist, we're going to put that no solution symbol. Oops, sorry. Sorry, I'm really bad with this pen. Sorry, guys. All right, last two. As the limit approaches negative infinity. So let's think about this. Here's your function. This is your function. We're going to follow it here with our red line. As this approaches negative infinity and my x values get smaller and smaller and smaller, here's your horizontal asymptote. Remember, it actually could go up and down and cross over that, but as it gets smaller and smaller, it's going to approach that value at the end. So the value that it is going to approach would be negative 1. And taking a look at the limit as x approaches infinity. Again, you can think of it as x approaches infinity. Sorry, I walked away for a second. Here's your function. As we approach positive infinity, we're going to keep going, keep going, keep going. We can assume, based off of this graph, since we don't see it dipping lower, we can assume that it approaches 0. There are a couple different answers for this. I mean, you could say that it's going to continue to slightly go down and eventually approach negative infinity. There's a couple of arguments there, but because the graph, the picture of the graph is blocked off and is stopping at this value, like somewhere around here, we're going to make the assumption that it's going to approach 0. Okay, so you have a couple of graph examples you can go back and take a look at if you need to. I've put on my website the remaining worksheets that I would like you to work on. It's a 6-question graphing worksheet. There's also a limits at a point packet and then a coordinate plane worksheet. You should be able to work through them pretty quickly. I know it sounds like a lot, but it isn't. Whatever you don't finish, please complete for homework, because tomorrow we are going to get into wrapping up graphing, limits graphically, and then also move into limits algebraically. You may also have a quick entrance quiz or mid-period quiz tomorrow on just a basic function and identifying some limits of that function graphically. Okay, so good luck with the rest of the assignments, and my answer keys will also be posted on my website.